Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answer for short answer type questions, which is there in second year syllabus. I'll continue with explanation for short answer type questions in ray optics. So let us continue with the first question. The question is why the setting sun does appear red. The main reason for the setting sun to appear red as is scattering. So first you try to get the definition of scattering. Scattering definition is when light is incident, when light is incident on the small particles, on the small particles in the atmosphere, on the small particles, on the small particles, say water drops, small particles, the light is absorbed by them, light is absorbed by them, light is absorbed by them, and it's spread in all directions, in all directions. So this phenomena is called, this phenomena is called scattering. Now, according to the scientist Rayleigh, according to the scientist Rayleigh, according to the scientist Rayleigh, the amount of scattering, the amount of scattering is inversely proportional to, is inversely proportional to, is inversely proportional to fourth power of the wavelength, fourth power of the wavelength. When size of the particle, when size of the particle, when size of the particle is much less than wavelength. So it means understand that A is the size of the particle which is much less than wavelength. Now, during the time of sunset or sunrise, so understand like this. Let us say this is the outer part of the outer surface of the earth. Here there is, understand that there is some observer here. So sun is at horizon at the time of, so horizon means sun is somewhere here. So horizon means at the time of sunrise or sunset, the sun is at horizon. Sun is at horizon. The light horizon. The light rays. The light rays other than red. Other than red. Suffers maximum scattering because their wavelength is less. Maximum scattering. Suffers maximum scattering. When they travel, suffers maximum scattering when they travel larger distance. When they travel larger distance until they reach the observer on the earth. Reach the observer on earth. As we know, scattering is inversely proportional to fourth power of wavelength. As the scattering is inversely proportional to fourth power. So the shorter wavelength light scatters more, it leaves the larger wavelength light. So that is red. It leaves the larger wavelength light, that is red, to reach our eye. To reach. So this is the main reason for the appearance of sun as red at the time of sunset and sunrise. Let us continue with the next question. Next question is define critical angle. Explain total internal reflection with a neat diagram. So first, let us try to have the definition of critical angle. Critical angle. When light travels, from denser medium to rarer medium, rarer medium, like water, light coming from water to air, denser medium to rarer medium, at a particular angle of incidence in the denser medium, for which angle of refraction in the rarer medium is equal to 90. So let us try to understand. Suppose, for example, this is the thin layer separating both water and air. Understand that refractive index of air is equal to 1. So you can also call it as mu1. Refractive index of water is 4 by 3. Understand that this is mu2. So let us say there is an object here. There is an object in water. So that is optically denser medium. So light is incident here. So conditionally we have to take normal here. So you all know that when light travels from denser medium to rarer medium, it bends away from the normal. Understand that this is the first trial. Suppose if we take the second trial like this. So for this ray also take normal. It bends again away. So for the second trial, it is coming closer to the layer which is separating the two medium. Now make the third trial. So from the same object which is in denser medium. So this is normal. So now here there is a chance for the refracted ray to pass along the layer separating the two medium. So therefore here, let us say this is R1 for angle of incidence in the denser medium I1. Let us say this is R2 for angle of incidence in the denser medium I2. Now this is I3. This is also called as critical angle. Now for this angle of refraction is 90. So this is called as critical angle. So when light ray travels from denser medium to rarer medium at a particular angle of incidence for which angle of refraction is 90, then it is called as critical angle. So now mathematical part, let us understand. When light ray is from second medium to first medium, so we have to write refractive index of the first medium with respect to the second medium. Refractive index of the first medium with respect to second. So this is the way to write mu1 by mu2. is equal to sin IC, call it as. So understand this is a critical angle by sin R. So as we said in the definition, R is equal to 90. So mu1 equal to 1, that is refractive index of air. Mu is refractive index of the denser medium. Sin IC will continue. Now sin 90. So sin 90 is 1. So therefore we'll get finally, this is the relation. Even we can expect numerical also on this. Mentioning the value of mu, they ask what is the critical angle. So this is the relation between refractive index of the denser medium with the critical angle. Now, let us continue further. Suppose if we take another trial, so by that we'll get the definition of critical angle. If you take another trial, so another trial means from the same object, so this angle of incidence appears greater than critical angle. So therefore, this angle you call it as theta, which is greater than critical angle. So therefore, from this particular idea, we'll get the definition of total internal reflection. So TIR, when light ray travels from, so therefore there is a chance for this ray to come down. So therefore it bounces back into it reflects back into the same denser medium. So this phenomena is called as TIR. So let us continue having definition. When light ray travels, from denser medium to rarer medium, from denser medium to rarer medium, at a particular angle of incidence, at a particular angle of incidence for which angle of incidence which is greater than critical angle, light reflects back, light reflects back into the same denser medium, into the same denser medium. So this is called TIR. So which means this is next case of critical angle definition. So here at I3 we'll get a critical angle. So in critical angle light passes along the surface separating the medium. The next case this is theta. So at which there is a chance for light ray this to reflect. So this phenomena is called as TIR. So what are the conditions for the occurrence of TIR? So conditions for the occurrence of TIR. So first thing is light should travel from denser to rarer. Second is angle of incidence in the denser medium. Angle of incidence in the denser medium must be greater than critical angle. So if these two conditions are satisfied, TIR may take place. Okay, so let us continue. Instead of question number 3, let us continue with the explain, because this fourth question is a continuation of TIR only. Explain the formation of mirage. So I'll explain question number 3 and 5 afterwards. So let us continue with 4. The question is explain the formation of mirage. So let us first draw that. So when mirage is formed, we observe the top of the building or top of the tree. Somewhere on water bodies when you travel on the roads, particularly in summer, on hot summer days. Let us say this is the ground. So somewhere here is observer in hot summer days. Let us say here this is going to be the tree. Even we can draw the branches of tree also. Let us say this is These are the leaves. Now, so what happens is the layers. So divide the layers of air into many. The layer which is close to the ground or close to the earth is hot, because on hot summer days it appears that roads are hot. So when you go up and up, so layers become cold, they become denser. So this is how, just for example, I am dividing the layers of air like this. Layers of air like this. So the explanation is, on hot summer days, on hot summer days, the layers of air, the layers of air in contact with the ground, in contact with the ground are hotter, are hotter, and they become, and they become low dense. Their refractive index, their RI is less. So when you go up and up, so let us say this is hottest, this is topmost coldest. So which means from the top of the tree, let us say light is coming from the top of the tree. So light is traveling from denser medium to rarer medium. So you all know that when light travels from denser medium to rarer medium, it bends away from the normal. So it bends further away from the normal. So there is a chance for angle of incidence to increase. So like this. So once it exceeds the critical angle. So what you can say that the light rays coming from, light rays coming from top of the tree, top of the tree, because at the top of the tree the air is colder and high dense. Top of the tree, at the top of the tree, at the top of the tree, the layers of air, the layers of air are cold, and they are high dense, high dense. Then so when light ray travels, when light ray travels from denser to rarer, denser to rarer, it bends away from the normal. It bends away from the normal. So one particular case we get critical angle. Let us say this is light is coming from denser to rarer. So let us understand this is at critical angle. So this is at critical angle. This is at critical angle, I see. Suppose when it goes further, this particular light further. So there is a chance for this light ray, angle of incidence may be greater than critical angle. So when angle of incidence is greater than critical angle, so there is TIR may take place. So it means one of the light ray, so it means that one of the light ray for which angle of incidence will be greater than critical angle. So there is TIR takes place away from the normal. So light ray incident greater than critical angle. So which suffers TIR, suffers TIR, which suffers TAR. So therefore, it bends and it goes into the same tensor medium. For a distant object, so let us say it will be like this. For a distant object, it appears like this. It appears like this. For a distant object, top of the tree will be downwards, and it appears that there is a water body formed here. There is a water body formed here. So therefore, for a distant object, for a distant observer, there is formation of water body. There is formation of water body in which top of the tree appears. In which top of the tree appears. So this mainly takes place on highways. So when you travel in hot summer days, so maybe nearby 1 kilometer and 2 kilometer distance, so there is a formation of water bodies. So when you look down, light comes from the top of the tree as usual. When you look down, so the top of the tree appears in the water body because there is formation of water body. So the top of the tree appears in the water body. So this is mainly because of the total internal reflection phenomenon. Students, thank you very much for watching my video. But don't forget to share and subscribe with your friends and relatives. Thank you very much.